Hello everyone, myself Dr. N. Gopinath, Assistant Professor, Department of Computational Intelligence, SRM Institute of Science and Technology, KTR campus. I am welcoming you all for my second video lecture session regarding Unit 2, the concepts of addressing. So the following are the topics which we are going to cover under the Unit 2. First, let us start with IPv4 addressing. The term IP stands for Internet Protocol and V4 stands for version 4. This is the most widely used system for identifying devices on a network. It uses a set of 4 numbers separated by periods to give each device a unique address. This address helps data finds its way from one device to another over the internet. What is an IP address? An IP address is a unique identifier assigned to each device connected to a network that uses the Internet Protocol for communication. It serves two purposes. One is identification. It uniquely identifies a device on a network. And second one is location addressing. It indicates where a device is located within a network. Understanding IPv4 addressing. An IPv4 address consists of series of 4 8-bit binary numbers which are separated by decimal point. Although any numbering systems can be used to represent a unique 32-bit number. Most commonly, you see IP address expressed in dot decimal notation. The examples are given in the table format. IPv4 address format. An IPv4 address consists of 32-bit grouped into 4 sections known as octets or bytes. Each octet has 8 bits and these bits can be represented only in 0 or 1 form. And when they grouped together, they form a binary number. Since each octet has 8 bits, it can represent 256 numbers ranging from 0 to 255. Binary representation. IPv4 is basically converted into binary form by computer, although these are usually seen in decimal form for human readability. Each octet is converted into 8-bit binary number. For instance, 185.107.80.231 in binary looks like 185:10111101. Similarly, 107, 80 and 231. So the binary representation is given here for your reference. So this is a IPv4 address format which is given in a pictorial representation for your better understanding. Next, parts of IPv4. The IPv4 addresses consist of 3 parts. First one is the network part. The network part indicates the distinctive variety that's appointed to the network. The network point co-jointly identifies the category of the networks that assigned. Host part. The host part uniquely identifies the machine on your network. This part of the IPv4 address is assigned to every host. And the last one is a subnet number. This is the non-obligatory part of IPv4. So here is a diagrammatical representation of how the IPv4 address is represented. It is a combination of two. The first one is the network part and the second half is the host part. Types of IPv4 addressing. The first category is unicast addressing mode. In this addressing mode, which is used to specify single sender and single receiver. Example, accessing a website. Broadcast addressing mode. This addressing mode is used to send messages to all devices in a network. Third one, multicast addressing mode. This addressing mode is typically used to send messages over a network. So here is a diagrammatical representation of types of IPv4 addressing. And the IPv4 datagram header is given here as a picture. So The datagram header consists of the following components. First one is a version, that is the version of the IP protocol, which is 4 for IPv4. HELEN, that is IP header length, which is of 4 bits, which is the number of 32-bit words in the header. Next is a type of services, that is low delay, high throughput, reliability, and so on. And the last part is the total length, that is the length of the header plus data. So these were typically represented here in this picture. Next, identification. Unique packet ID for identifying the group of fragments of a single IP datagram. Flags. 3 flags of 1 bit each. Reserved bit, that is it must be 0. Do not fragment flag and more fragment flags. Fragment offset represents the number of data bytes ahead of the particular fragment in the particular datagram. And the last one is time to live, that is the datagram's lifetime. Protocol, the name of the protocol to which the data is to be passed. Header checksum, 16 bits header checksum for checking errors in the datagram header. Source IP address, 32-bit IP address of the sender. Destination IP address, 32-bit IP address of the receiver. Next is the characteristics of the IPv4. IPv4 could be a 32-bit IP address. It could be a numeric address and its bits are separated by a dot. The number of header fields is 12 and the length of the header field is 20. It has unicast, broadcast and multicast style addresses. IPv4 supports virtual length subnet mask. RIP may be a routing protocol supported by the routed daemon. Networks ought to be designed either manually or with DHCP. The following are the advantages of IPv4. The IPv4 security permits encryption to keep up privacy and security. IPv4 network allocation is significant and presently has quite 85,000 practical routers. It becomes easy to attach multiple devices across an outside network while not NAT. This is a model of communication so provides quality service also as economical knowledge transfer. IPv4 addresses are redefined and permit flawless encoding. Next is the limitation. IP relies on network layer addresses to identify endpoints on the network, and each network has a unique IP addresses. The world supply of unique IP address is dwindling and they might eventually run out theoretically. If there are multiple hosts, we need the IP addresses of the next class. So these were some of the limitations of IPv4. So here is the activity time. Let us spot the error, if any, in the following IPv4 address. Let's go with question number 1. So here is the answer for the error which were identified. So for the first question, there must be no leading zeros, that is 045. For the second question, 4 octets only in IPv4 address. And for the third one, range of each octet is between 0 and 122. Next is the activity. So change the following IPv4 addresses from binary notation to dotted decimal notation, and similarly from decimal notation to binary notation. So the solution given here, we can replace each group of 8 bits with its equivalent decimal number and add dots for separation. And for the second conversion, we replace each decimal number with its binary equivalent. So the solutions are given here. Next is the classful addressing. Classful IP addressing is an absolute method for allocating IP addresses and dividing the available IP address space across networks. It was used from 1981 to 1993 until the introduction of CIDR, that is based on prefixes rather than classes. Classful method categorizes IP address into 5 classes, that is A, B, C, D and E, each defined by the first few bits of the address and services specifying range of purposes. Need of classful addressing. Classful addressing was an early, straightforward method of allocating and managing IP addresses. It simplified network administration by dividing IP addresses into fixed classes, that is A, B, and C, which made routing faster and easier for the network equipment of the time. This system allowed for network scaling within the bounds of each class, with larger networks using class A or B addresses and smaller networks using class C. Next is the classes of IP address. As we all know that the 32-bit IP address is divided into 5 subclasses. They are class A, that is meant for very large networks, class B for medium to large networks, class C for small networks, class D reserved for multi-class addresses, and class E reserved for experimental purpose. So here is a diagrammatic representation of classes of IP addressing. So the purpose of class A is designed for very large networks. First bit is always 0 and the structure is given as network ID, the first 8 bits, host ID, the remaining 24 bits. Default subnet mask is 255.0.0.0 and the IP range is from 0 to 127. Number of networks is 128. And the purpose of class B, designed for medium to large networks. The first 2 bits are always 10. Network ID is first 16 bits and the host ID is the remaining 16 bits. The default subnet mask is 255.255.0.0. IP address range is from 128 to 191. And the number of networks is 2 to the power of 14. And class C, purpose is designed for a small networks. The first 3 bits are always 110. Network ID, the first 24 bits and the remaining 8 bits are the host ID. Default subnet mask is 255.255.255.0 and the IP address range is from 192 to 223 and the number of networks is 2 to the power of 21. Class D and E. So the purpose of class D is reserved for multi-classed addresses and its IP address ranges from 224 to 239. Does not have a network ID or host ID. When comparing to class A, B and C, those 3 are having an individual network ID and host ID, whereas this class D doesn't have any network ID or host ID. And the purpose of class E is reserved for experimental use and future usage. The IP address ranges from 240 to 255. It is not available for public use. It is exclusively meant only for the experimental purpose. So rules for assigning the host ID. Within any network, the host ID must be unique to the network. A host ID in which all bits are set to 0 cannot be assigned because this host ID is used to represent the network ID of the IP address. The network ID cannot start with 127 because 127 belongs to class A address. So here is a structure of classful addressing. So the problems are millions of class A addresses are wasted. Many of the class B addresses are also wasted. The number of addresses available in class C is so small that it cannot cater to the needs of organization. Class D addresses are used for multicast routing. Class E addresses are reserved. So which is given here in a diagrammatic format. So as of now, we have seen about the concepts of IPV4, its components, followed by the classes, how the networks are classified into. I hope the session will be more interesting, and we are about to upload the videos which is having few more topics comes under the subject, that is computer networks. Thank you for watching.